All right. What else? All right, here we go. So we're going to remind ourselves, because spring break happened, and I went to Florida. I'm not sure where y'all went, but I had a good time. But now we have to think back, crack down last 9 weeks. Okay, we finished strong here. Let's remind ourselves what functions are, okay? What up there do you see in problem 1 that screams out the word function to you? The f of x, at f parentheses of x. And he's exactly right, Travis. At f of x at g of x is called function notation. And if you remember, before break, we went ahead and we looked at these 2 types of problems, when we add them and when we subtract them. And what do we have to be careful of? What do we have to be mindful of? April? When we subtract, we have to distribute the negative. Same thing, okay? We're going to change all the signs and then what we're subtracting. So let's just remind ourselves. Adding, what do we have to be careful of? Really anything? What am I doing when I add? I'm combining like terms, okay? So let's go ahead and just look at the subtraction one to remind ourselves. You don't have to write this down if you don't want. The new notes are coming soon. This is more of a reminder. If I take my f and I subtract g, why did I put parentheses there? Perfect, Patrick. Exactly what as April said and what Patrick said, I'm going to be distributing that negative. So I'm going to go ahead and just change all the signs on the inside of the parentheses to remind myself that's what I do. And then I'm going to combine like terms. I have a cubed and a squared, which I cannot subtract, so are combined at all. So I'll just write those down. The 1 and the plus 4 becomes a plus 5. So that is f minus g. The subtraction. Actually, the 1 just combines with the 4 because they're like terms. Okay? So these 2 things were like terms, so I combine those to give you the 5. All right? Now, well, I changed it to a plus because I subtracted all of the second one. And that's what you have to be careful of when you're subtracting functions. Okay? You just change all the signs and what you're subtracting. You're adding the opposite. Now, when we look at these 2 functions, f, what does this notation mean? The f, and then what does that dot mean? It means multiply. And we're going to look at a different thing today that's f circle g, and that's something different. I kind of warned you about that before break. And then we have f divided by g. Okay? So, f times g, what would that look like? What would I do? What is f times g? I write it like this. I would have to FOIL or put parentheses around each of them to denote that I am multiplying both of them. And I'm basically going to FOIL or distribute, really. FOIL really only deals with binomials. We have a trinomial here. Now, some of you like to write the little one first. Is that what most of you like to do? And distribute the x and distribute the negative 2? Perfectly okay with me. I'm just going to do it backwards, but it doesn't matter. X times all of these things, and then negative 2 times all of those things. So what's x times x squared? X to the third, okay. And then we have x times x, which is x squared, good. And then I have x times negative 6. No. Just x times negative 6. Negative 6x. Now I'm going to distribute the 2, or negative 2. Don't forget that the negative is also distributed. What's, well, not, oh, and yes. We can write it in that order. Positive 12, negative 2x, and 2x squared. Okay? At this point, I'm halfway done. Okay? I normally don't mind if you're eating breakfast, chicken wing, but now we're getting out the Chick-fil-A sauce. You want to put out a spread? You going to share? You got some like chips and salsa to add to the mix? I don't want any. You're crazy. All right, what do I do at this point? Perfect. I'm going to look to see if there are any like terms to combine. So is there anything with the x cubed I can combine? No. But there are some x squared terms that I can combine. And there's some x terms I can combine. Well, hang on, not yet. We got to put the x cubed down there too, right? So I'm going to say x cubed. Negative what? Oh, let's go in order. So we have cubed, then the next one would be x squared So let's combine the x squared terms.
X squared. It'll be negative.
Negative x squared. 1 plus negative 2 is negative 1, all right?
Plus, no, it's minus 8x.
There you go. And then plus 12. And there's your answer, okay? It's just a matter of that's it. You're distributing and combining like terms. It's really all you're doing with multiplying.
You didn't get the catch yet. It's always a catch.
Well, not with multiplying and adding, but with subtraction there's a catch only to remind you to distribute the negative. What is the catch, as you like to say, for f divided by g? What do I have to be careful of? The domain. Very, very good. So I'm going to put f in the numerator. I have x squared plus x minus 6, and I have x minus 2. All right. Yes, what's up? What 2, baby? Up in the multiplying one? Negative 2x? This? Oh, I combined it with the positive x squared, and it became negative x squared. Because 1 minus 2 is negative 1. Looking at what's highlighted in yellow, I combined those. Okay? All right, so back to the dividing one. I'm not done for 2 reasons. One, I think Oshomori said I had to be careful about the domain, right? So I know I need to do that. What is the domain restriction when I have a division problem like this? What do I have to be careful of? What can't I ever do? I can't divide by what? 0. So what would make this, what would x have to be in order for me to divide by 0? What can't x be? So x minus 2 cannot equal 0. Do you agree with that? The denominator cannot equal 0. So in other words, x cannot equal 2. That's your domain restriction. Remember that? Why else am I not finished? What do you think you would do when you see something like this? Any ideas, Daniel? Christian? Okay, if I was going to graph it, absolutely. I'd look for asymptotes. And if I was going to even think about going that route, what would I have to do first? Yeah. Well, that's if I'm adding or subtracting 2 fractions. I'm not doing that here. But factor. Is the numerator factorable? It is. So let's go ahead and try that. Let's factor it. What does the numerator, now the bottom still says x minus 2, but what does the numerator factor into?
2 and 3.
Which one's negative and which one's positive?
3 is
3 is x plus 3 and x minus 2. Remember, they have to add to be the middle term and they have to multiply to be the last term.
So they just take out, but it's not, you don't graph it.
You don't have to graph it, but you're just simplifying it.
So that would be a whole, though?
Yeah, it would be a whole if I was going to graph it, which is still why it's a domain restriction. Still can't divide by 0, right? So the answer is going to be x plus 3, but x can't equal 2. All right? So that's how you would write that. The answer is x plus 3, but my domain restriction is x can't be 2. You can if you want, but you should have it in your notes from before spring break. Shamar? Not always. I think even the ones we did before break, the top didn't factor. I think we just left it like that. My point is, if you can factor it, I want you to. Then you just leave it. Yeah. If the top wasn't factorable, you could have left your answer just like this. Just dividing, f divided by g. Functions stuff. Are we okay? I can't believe y'all are sitting here with like hoodies and jackets all zipped up. It is so hot in here, you guys. Whew. Spring break, they got to work on the AC. True, I did. But it wasn't hot. It was only like 80 degrees. It's like probably 90 in here right now.
It's nice, comfortable in here.
April, you need to eat a cookie or something. Good. All right, are we ready? All right, here's where the notes need to come into play. All right, so you want to write some stuff down. I'll not everything that you see here. I will tell you what I want you to write down is good to reference when you're looking at homework and things like that. But let's just go ahead and just take a break for a minute and kind of read what you see up here and tell me some things that you recognize and some things that you don't even know what it means. Okay? So anything up there, I'm going to pause for a minute, let you guys read it, and then I want you to kind of come up with one thing that you recognize and one thing that you're not sure what it means. All right, give me one thing that you recognize. You recognize the word domain. Give me something else that you recognize. The word range. Trent's not here. I recognize domain and I recognize range, okay? Anything else that you recognize, that you see? Input, output. That's like when you input something into a function, you get something out, like that function machine. We're going to be doing that with functions. We're not going to be putting numbers in at first. We're going to be putting functions into functions, a little bit different. Anything that up here that you don't recognize? Give me a word or an expression or some symbols that, the circles you don't recognize? That's like a Venn diagram. It's like that's not really meant to, it's kind of a, what is that thing called? It's a flow chart. That's really all that is. Yeah. That's what I was hoping you'd say. That looks to me like something we probably have not seen before in terms of notation. That means composition, okay? Composite function or composition, they mean the same thing. We are going to be composing two functions. Here is something you should write down. F of g of x is the same thing as f circle g. And you need to know both notations, because I have seen both come up before. They mean exactly the same thing. I would write down what I wrote down. Okay? Notice that's a circle and not a little dot. The dot means multiply, but if it is a small open circle, that means composite. Okay? And I actually prefer the left-hand side notation because it's telling you what we're actually doing. Same goes the other direction. This g of f of x is the same thing as g circle f. Sometimes these functions are referred to as fog and goff functions, just because it looks like it's fog and goff. Okay? But it just really means I'm taking one function and plugging it into another.
So whenever it's not one, it's other.
Yeah. Notice what happens. What goes inside the function is what goes on the second term. What goes inside the function is what's in the second term. Okay, that's the notation there that we should be aware of. Now, what do those parentheses mean? Okay, it just means I'm literally plugging one function into another. That's all it means. I'm going to take g and plug it inside of f. We're going to treat it like an onion, like you're going to peel back the layers, and we're going to start with the outside and work our way in. So let's go ahead and do an example, okay? So, if it says here, we want to find, here are our two functions, and so you should write these two functions down. We're going to do a couple of examples. Write down your f and write down your g. F of x is x squared, and g of x is x plus 3. And what we want to do is find goff in the first example. And I told you that goff meant what? Goff means g of f of x. Do you agree? If we're going to find, let's just go ahead and write it bigger. I like to write a little bit bigger. Goff is g of f of x. Right? We know that. So I'm going to start with g. I'm going to start with the outside. And so I'm going to write this function, but everywhere I see an x, I'm going to put parentheses. Okay? Not yet. No. Don't try to do it without me helping you, okay? At first. So I'm going to start with my g function. I see an x, so rather than an x, I'm going to put parentheses, and then I'm going to say plus 3. That is like x plus 3. Okay? X plus 3. That's exactly what g says. Do you agree? Now, what goes inside the parentheses is your f of x. So instead of x, instead of my parentheses, what am I putting inside of it? x squared. Very good, because that is what f is. Everywhere you see, we're going to start with the outside layer. In this case, it was g. And I'm just writing my function g of x, except for everywhere there's an x, I'm putting parentheses.
So the F just goes away?
The f goes inside of g. That's why you have an x squared.
Oh, that's the F of F.
Uh-huh. F of x is x squared. And so if I was able to combine something or do something, that's what I would do here. I can't combine those. So my final answer is just x squared plus 3. Okay? No big thing. What other x? Remember, it was parentheses plus 3. So that x is replaced with the other function. Okay? Let's try, and it's going to take some while to get used to. Let's try it again, but let's go the other direction. I'm just going to highlight my f and my g so you can see them. And this time, let's go the other direction. Let's find fog, or f of g of x. We're just doing it in both directions, and we're going to be doing it in both directions for a reason. It has to do with whether they're inverses of each other. We'll talk about that on Wednesday or Thursday. Today's Tuesday, right? So what did I do before? I started with the outside layer, right? And what's our outside layer this time? Okay. So rather than write x, I'm going to say parentheses squared. Remember, we're starting with our outside layer. Our outside layer in this case was f. And I'm going to put my f. And rather than write x, I'm writing parentheses. It is squared, yep, Okay, what goes inside those parentheses is g. X plus 3 goes inside those parentheses.
Oh, so x squared.
X, well, we have to FOIL it. It's not x squared plus 9. It's x squared plus 6x plus 9. Because you've got to multiply it, you've got to FOIL it. But before we jump ahead to that, let's make sure we understand what I did first. Alexis. Okay. So I'm literally going to cover it up with my hand. Okay? I'm starting up with f. Here's f. Rather than write x squared, I wrote parentheses squared. What goes inside the parentheses is all of g. So all of g was x plus 3. I started with the outside, and I worked my way inside. You always start with your outside function, and wherever you see an x, you put parentheses. Okay? Start with the outside. Okay, you're jumping ahead. Hang on. I'm glad you're working ahead, but I want to make sure this part's the hard part. Do we know what goes into what function?
You just put the outside number.
Outside down, and then you put the inside inside. That's all it is. But when there's more than one x, it gets a little complicated. So we're starting off small. Now, a lot of you are already trying to multiply that, which is awesome. When I have a binomial squared, I can't just say that's x squared plus 9, because it's not.
You ready?
I'm ready. Hit me.
All right, so x squared plus 3x plus 3x plus 9.
Okay, and I'm going to actually take it even a step back for a minute, Tim, so everyone can kind of see what you did, but you're right. Anytime you have something squared, it's that thing twice, and then we're going to FOIL it or multiply it, distribute it the terms, however you want to think about it. And he's right. You get x squared plus 3x plus 3x plus 9. And then you're just going to combine those. X squared plus 6x plus 9. That is your fog function. Okay? Fog and Goff. Again, do you see why I like this notation, f of g of x and g of f of x better? Because it shows you what you're plugging in. Okay? So I'm going to pause the recording. I have two new functions. And I want you, this one's a little harder because you have x squared, you have a 2, you've got a bunch of stuff going on. Can we do this? Find f of g and g of f. You can. I have faith in you. Okay? So let's try these. I'm going to pause the recording. I'm going to turn the lights back up. I want you to try these too. Same exact process as before. Start with your outside. Write everything down. Put parentheses where the x's go.
Hold up. No, I don't want you to show me right now.
I think f of g of x is harder. I think we should start with g of f, okay? There's a reason. We'll come back to the other one, but it's a little bit harder. So let's start with this one here, okay? I'm going to set it up, and I want you guys to finish it. We're going to start with, we know that g of f is g of f of x. So I'm going to start with g, and I'm going to plug in the f. So if I start with g, everywhere that I see an x, I'm going to put parentheses. I probably need to make those parentheses a little bit longer, more room. Why do you say that? Why would I say that? There's a lot of stuff to plug it in. Don't you agree? So I'm just going to make some more room for myself, really. So 3 parentheses minus 1. 3x minus 1. Rather than x, what goes inside those parentheses? Well, f does, because f is on the inside. Okay? We started off with g, our outer layer. We put parentheses everywhere there was an x, and then we're plugging in the other one. So inside goes this, 2x squared minus 3x plus 5. All of that goes inside. Now, how do I finish off? How do I simplify this expression? What else do I need to do? Well, we don't need to factor it yet. We can't factor it. I got to distribute what? The 3. Let's do that first, okay? So let's distribute the 3. So if I do that, I have 6x squared minus 9x plus 15. And oh, by the way, I still have that minus.
Yes and no's be killing me on
Scares me. I got to combine the 15 and the negative 1, don't I? Combine the like terms?
14.
Good. So 6x squared minus 9x plus 14. That is my Goff function, my g of f of x. Okay, that's what I did. So I'll leave that one up there, and I still want you now to come back and do the other one. It's a little harder because there's more x's, more parentheses that you're going to have to do. So again, I'm going to pause it. I want you guys to try. All right, so on this problem, we're starting with our f. How many x's do you see, Raul? How many x's do you see in f? Shh. I see more than one. I see 2. I see an x squared and an x. So I'm going to put 2 parentheses down because I see 2 x's. So I'm going to literally put everything that I see except for the x, and in place of the x, I'm writing, I'm just going to put a big line here so I know, I'm writing, that is f. I have 2 parentheses, I see 2 x's in my f of x, right? There are 2 things there. Now what goes inside those parentheses is g, and g is 3x minus 1. Most of us got that far. We have to remember, when we simplify this, that we have to use order of operations. That please excuse my dear Aunt Sally or Gemma. I'm not sure what you were taught. There's all these different acronyms. Anyone learn Gemma, by the way, in middle school?
No, it's always
G-E, okay, please excuse my dear Aunt Sally. That's how I grew up learning too, but they're trying to change it for some reason. So parentheses, exponents. Do you see some exponents in there? Yes. Multiply comes after exponents. So we're not going to multiply by the 2 yet.
squared that.
We have to square. Well, I see a squared in the problem. Right?
That's me all up.
So we have to deal with that squared before I can deal with the 2. So that's what we're going to do. It will be wrong if you distribute first. It will not give you the correct answer. Okay? Because that's why order of operations matters. Okay? So, question? No?
So, wait,
I have to do some work off to the side over here. What is 3x minus 1 squared? 3x minus 1 times 3x minus 1. Got to do some work first.
9x
Squared
plus 2x.
minus 3x. We're just multiplying everything. Inside, outside.
9x plus 1.
Well, the negative 3 and the negative 3 don't cancel.
They do cancel.
No, they're both negative, yeah. So I have two parentheses. I'm going to put that in there. 9x squared minus 6x plus 1. This one's a little bit more involved. Now I'm going to distribute the negative 3. Minus 9x plus 3 plus 5. I distributed the negative 3 because there was something it was multiplied by. All of that 3x minus 1 was inside there. Okay? What's the next step? Distribute the 2. Perfect. We're almost there. I feel it. When I distribute the 2, I get 18x squared minus 12x plus 2, and then everything else. Can I go ahead and combine the 5 and the 3? Is that okay with you guys? Make it an 8. So minus 9x plus 8. Am I done yet? I do. What else do I need to do? Combine like terms. Right. So combine these two and combine those two. But I'm almost there. So my final answer is 18x squared minus 21x plus 10. Is that what you had, Alex? It's hard for me to you got it. All right, good. This one is a lot more involved, but it's not something that you can't do. It just takes a while. Okay? So all we have to remember is start on the outside and work our way inside. Okay? So I'm going to pause for a minute and let you guys try some problems on your own first. And then we're going to look at it from a graphic point of view. We're going to look at it from a graph. Can you take a graph and plug in and find the function? So we'll do that in a couple of minutes. There's really nothing different about this one. It just has a little division there. So here's G. We're starting with our outside layer. G was x over 5. So rather than write x up there, what am I going to put up there? Whatever f of x is, which is negative 3x plus 2. I said put parentheses in the original problem wherever there was an x.
I know that, but it's there, it doesn't have.
That's the only way to do it. That's it, and you're done. Nothing else to do. That's it.
Seriously?
That's all. Yeah, that's it.
Oh, right.
I think you guys were just making it harder, right?
How do you know when that's it?
That's a really good question. How do you know you can't simplify anymore? You want to check for things like, can I combine like terms? Is there anything to distribute? Is there anything to FOIL? None of that here, right? So that's why you're done. I think that's the best question I've heard all day, quite frankly. How do you know when you're done simplifying? Look for distributing, exponents, things like that. All right, let's look at 17. We want f of g of x this time. I think y'all can do this. Put your parentheses wherever you see the x, and start with your f. Look at your f of x. Notice there's a negative in front of the 3. Don't forget that. It's not multiply. Remember, it's composition. All right, as I'm walking around, almost all of you have the following, which is correct. You have, starting with our f, negative 3, parentheses, plus 2. And then inside those parentheses went x over 5. And a lot of you were like, am I done? How do I know when I'm done simplifying? This actually could be simplified a little bit more. I would accept this as your answer. There's nothing to FOIL. But isn't there something I can kind of distribute a little bit? Does the negative 3 go with the x, the 5, or both? Just the numerator. So it's just negative 3x over 5 plus 2. Done. Okay? No, I'm sorry, just at the end. Kind of looked like it went to the bottom there, didn't it? Plus 2. Okay? Not too bad. We can do it. What do I do with the ones previous to that that have numbers? Okay? There's two ways to do that. I'm going to show you the easier way, quite frankly. So what happens, like on a number 7, where I have f circle j of 3? Okay? When I have a number there, notice what I had before. I had an x. Do you agree? In each of these problems I've already done, I had an x. So I had x's in my answers. When you're plugging in a function, you should get a function out. Here, what am I plugging in? A number. A little bit different. This is going to be f of j of 3. That means composition. This means I'm plugging one into the other. What am I plugging into my function? Well, I'm plugging all of this. But what is that? I have to evaluate j at 3. So let's do a little side work. What is j of 3? Let's find that. So I'm looking at j. I have 5 minus x, or 5 minus, not x this time, but 5 minus 3. So isn't j of 3 just 2? All I did was plug in the number 3 into my function j. 5 minus x. In this case, 5 minus 3. So I'm going to replace j of 3 with the number 2, because I've already figured out what j of 3 is. So this is really the same thing as f of 2. Okay? So I'm going to plug in f. F was negative 3x plus 2. Hang on, don't jump ahead. Don't jump ahead quite yet. What goes inside those parentheses? The number 2. Because that's f, but I'm plugging in the number 2. Multiply and combine like terms. So you're going to get an actual number answer with problems 7 through 15. Okay? It's different than if I had an x there. So I want you guys to try the next few. 8, 9, and there's not a 10, 11, 12. I apologize. I took out that row. I thought it was too many problems. But I want you to try the next couple. Okay? Pause the recording. I want you guys to try. So I'm trying to find j of h, j composed with h of negative 1. I need to find h of negative 1 first. H of negative 1, when I plug in a negative 1, I have it up on the calculator screen, is this. And when you hit enter, I get 7. You probably won't. If you do, go to Math Frac. I don't think you do. I'll double check that one, but I don't think so. So maybe let me do this one first. I'll come look at it. So now, rather than h of negative 1, I'm going to plug in a 7, because I found out what h of negative 1 was. So what is j of 7? Well, let's look at j. J is 5 minus x, or 5 minus 7. I should get the answer negative 2. You're basically plugging the number in twice. I'm plugging in the number into the first one, getting an answer, and taking that number and plugging it into the second one. Say what? Are you talking to yourself? I'm just talking out loud? Okay. All right, so let me come check your 13, Tim. Let me make sure. I don't think you get a decimal. We're going to do two more things today. We're going to look at composition from a graph. As April says, why you always got to graph something, Miss Mackert? Because that's really what functions are, is one way to look at them. We can look at them from equations. We can also look at them from a graphic point of view. And then we will look at problem 18 together. Okay? So let's start with the graph part. And let's look at these two functions from a graph standpoint. What do you recognize f of x to be, the shape of the graph? What kind of a function is it? Absolute value. Very good. It's an absolute value function. It's that v function. Okay? And then g of x is just a what? It's a line. Good. All right. So if you notice, we're going to do the same thing that we did before, that you guys just did with the numbers. Because if you look at the problems I have listed at the bottom, don't those look just like the problems you just did? Except for rather than equations, what do I have? I've got graphs. That's it. That's the only difference. So I'm going to take, let's start with number 1. I'm going to take the 3, and what am I going to plug it into first? F or G? I'm going to plug it into G first. So I'm going to take the 3, and I'm going to plug it into G. So if I take 3, 1, 2, 1, 2, 3, what is the value on the graph? What is this value here? It goes up to 2. Would you agree? Isn't G of 3 2? Do you see that from the graph? So I'm going to say, okay, now what is f of 2? Because I went ahead and evaluated G of 3. Now I'm going to say, what's f of 2? F of 2 is this number. What number is that? 3. The answer here is 3.
So you start from the center?
Uh-huh.
Okay.
You're taking 1, you're plugging it in, then you're plugging it in again. Okay? Let's try the second one. It's the same exact thing that you just did. It's just from a graph now.
Well, we don't have to, you just put F.
So let's start. I'll do it one more time. So watch. I'm starting with the center, as Daniel said. Start with the inside. G of 3. What is that? Well, I came over here to the G function, and I found my 3, and I looked up at the graph, and I circled that point. What number did I get? I got a 2 there. So what is G of 3 was 2, so that's what I replaced it with. Then I went back here and said, okay, at 2, what is F? It's 3. So that's why 3 is my answer. You're taking the number, plugging it into here, getting an answer, taking that answer and plugging it into here. It's what composition is, taking one thing and plugging it into another.
That's what I'm just,
Where did I get this 2 from? It's the y value.
So you just put it, where'd you put it in the graph to get?
I plugged in the 3.
Oh, so
Not the calculator now. When the graph, we're not doing it from a graph. It's a little bit. We just look at the graph. We don't plug anything on the calculator. So I just went to 3 on my x. I went up, found the value, and the y is my answer.
that, right?
Yeah, that's what we know. So let's keep going. Let's try it again. Let's try it again. It kind of is. It's just that some people really get confused with the notation. I'm going to start with -1. What am I going to look at? Well, we're going to plug it into F or G first. F. So F is this function on the left. And I'm going to plug in -1. Here's -1, and I got 2. Good, Shamar. So F of -1 is 2. What is G of 2? So now I'm going to go over here to my G function, and I'm going to look at where 2 is. What's the answer? 1.
Turn up.
And that, see?
Yeah, okay.
That's easy though.
I'm telling you, this is stuff that when I taught IBSL, they couldn't do it.
Okay, but what is that?
You're smart. You're smart. If you can, this is a tough concept. If you really do understand this is tough, I'm proud of you. Okay, this is great. Let's start with the next one. F of 0. What am I going to do? Go to F. So let me erase what I marked on here before. I'm going to go to my F, and I get, very good. So what's G of 1? G of 1 is 0, yay.
Hey.
Right? From a graph, it's the same thing we did before, just from a graph, that's all. You will have 2 graphs. It won't always be a V, but it'll be some graph. Question, Daniel.
Is it always going to be f of x and g of x, or is it going to switch up to numbers?
Well, it won't be numbers, they'll be functions if it's a graph. But it might be called J or Q or R. Often it's F and X, F and G though.
Is it always going to be this simple, or is there
This is from a graph point, this is as hard as it will get for us. That's it. I promise. Okay? We do add, but this is really it. And I think this is tough from a graph point. You guys did great. Good. I think that's wonderful. All right, let's try the last problem together, okay? Number 16. Oh, 17. 18. I can't even look. I need to get my eyes checked. I did just get new glasses, I promise. Yes, you will. So you will turn this in today for a grade, okay? If you did not finish 1 through 6, then you can finish that on your own, okay? But this is for a grade for you. You will, and if you didn't, you'll finish it in addition for your homework. Turn it in. It'll still be due next class if you didn't finish 1 through 6 yet. All right, let's look at 18. Read it to yourself. Read 18. Get your 18 out. Let's go. Yes, Tim, would you please?
The video store adds a 25% markup on each of the games that it sells. In addition to manufacturer costs, the store also pays a $150 shipping charge on each game. Write a function to represent the price f of x per video game after the store markup.
Okay, so we're going to write a function, and we're going to call it f. Okay, so this is for A. How do I take a $1.50 shipping charge? Isn't it $1.50 no matter what? That's like a blanket fee. We're going to add $1.50 to everything no matter what.
Isn't it like 150 times?
Well, no, it's plus because it's just a flat fee. So you add that at the end. And then it's actually 1.25 because it's a markup. We're adding it to the price of the item. So it's actually, if you were subtracting it, you would subtract it from 1. So you're just going to put 1.25x. That's your function. It's a markup. We're adding it. It's an addition to the price of the item. 25% more than the cost. Okay? That's all.
Okay.
Because it's a markup, it's an addition to, so you add it to 1.
and that's the answer?
No, that's for A. Yes, that's the answer for A.
All right. B. You ready?
Shh. If it was a discount,
No, they would say like, just for one, just one of those.
right. If yes. Yes, exactly. You would find 25% of it and then add it to it. That's exactly right. Very good, Daniel.
All right. Don't worry about it.
All right, so now let's look at B. Go ahead and read it for us.
Write a function to represent the manufacturer cost plus the shipping charge.
Oh, so the A was not the shipping charge, right? Sorry. That's just the markup. That's just the store markup. Sorry. Yeah, so it's just that. I apologize. Wasn't paying attention. But this one for part B is this function. I'm sorry, this is g of x, right? So g of x is the markup plus the shipping charge. You can put a 0 if you want, 150, 1.5, same thing. So if you look at C and D, I want you to read them first, and let's talk about why they're different, because they are different things. So read C to yourself first, and then we're going to read D. And I want you to decide what's different about them, because they are, in fact, different. If you look at part C, it says, suppose the cost is $13. Okay, that's the manufacturer's cost. Okay. It says use a composite function to find the cost at the store, which would be how much the store charges, if the markup is applied after the shipping charge is added. So that means that the markup is applied after the shipping charge is added. So we're going to do the 1.5, then we're going to do the cost, the markup cost. Okay? So it's a little bit different. So 13, we're going to do f of g and g of x. Let's figure out which one is which. Oh, and rather than x, what are we going to plug in? What was the cost of it? $13. We're going to find these both. We're going to find them both. Figure out which one is which is my question. Okay, we're going to plug 13 in to one and 13 into the other. When I plug 13 in to G, I get 1.25 times 13 plus 1.5. And I get 17.75. Then I'm going to plug that number into F. And I get $22.19. That's how much the video game would be if I went ahead and did the shipping before I did the markup. Because you plugged it into the shipping first, right? The 1.5 was the shipping? So let's just write it down. So this is shipping before markup. And I think that's D. I think you're right. And this is going to be the shipping after the markup. So let's plug in 13 to F. 1.25 times 13. Oops. And I get 16.25. Plug that into G. And I get $22.81. There is a difference to whether or not you apply the shipping costs prior or after. Do you agree? One's more expensive. So you decide which one is C and you decide which one is D. Okay? This is due for a grade. But if you did not have time to finish 1 through 6, you have a couple of minutes, but really we need to be kind of winding down. You do have a separate homework assignment, however. It is out of your textbook. I will end up texting it to you as well and putting it on School Fusion. But if you are finished, you can go ahead and turn it in before you leave today if you were able to get done. All right, so here's your homework. While you're putting your calculators back, make sure you have it written down. It's obviously to finish the classwork if you didn't finish it in class today. I also want you to do problems 28 through 46 even. All right, so 28 through 46 even. They are composition functions. The one thing I will tell you is that they use A instead of X. It's not a big deal, but when you see something like this that says G of H of A, don't let the letters freak you out. A is just like an X. Just leave it as, just treat it like an X. It's just a different letter, that's all. It's exactly the same thing that we did in class today. It just has an A instead of an X. I was looking at the book, that's what they did for some reason. Don't let the A freak you out. It's just the same thing. All right? So that's